Hello, this is Benjamin Farland. Homework number 10, problem 2, the video problem. First thing to do is create the Moore circle. First thing I did was create the axes, and then I also found the x and y point. The x point from the values here, which was 27 megapascals, and then I also have 18 megapascals, negative 18 because it is going clockwise. And then the y is negative 45 megapascals and positive 18 megapascals because the shear is going counterclockwise. The sigma average is the two normal stresses added together, which is 27 minus 45 over 2, which comes out to negative 9. Once I have those three values, I can plot the center of the Moore circle, the x and the y of the Moore circle. After that, I can complete the Moore circle, add my points for the principal stresses and max shear stresses. I also found the angle of 2 phi p, which is the inverse tangent of 18 over 36, which ended up with phi being 13.28 degrees. And the angle of theta s for the shear stress ends up being 58.26. In order to get the principal stresses, I have to add OC plus CF, which end up being OC plus R. And in order to get R, I had to add CP plus PX squared, the square root of CP squared plus PX squared, which ends up being 36 squared plus 18 squared. So R ends up being 40.249, which our first principal stress comes out to negative 9 plus 40.249, which becomes 31.249 megapascals. I did the same thing with the second principal stress, OC minus CG, which is negative 9 minus the radius, negative 9 minus 40.249, which comes out to negative 49.249 megapascals. And then the tau max, which is just the radius, is 40.249 megapascals. To draw the elements, I take phi p and phi s. Phi p is for the principal stresses of G and F, F being the x-axis. With the stresses along the F being positive and along the G being negative. Then I also calculated the element for the max shear stress. The sigma average is both negative, which becomes negative 9 megapascals. Both D and E axes are negative, pointing in. And then the shear stress is 40.249 megapascals counterclockwise along the D axis and clockwise along the E axis. After that, I have to calculate the normal and shear stress for the A and B axis, for the plane A and B. And to do that, I take the radius times, for the normal stress, I take the radius times the cosine of the angle, which is 56.565 degrees, minus 9. I did the minus 9 because the center of the circle is 9 after the origin, is 9 to the left of the origin. that ends up being 13.177 megapascals. The shear stress for A, for B over here, is negative 40.249 times the sine of 56.565, which is equal to negative 22.177 megapascals. And because the shear stresses are the same, just opposite in the sign, the shear stress for A, tau 4, is equal to 22.177 megapascals. And we can do the same thing with the sigma 4, the normal stress for A. Just add a negative 40.249 cosine of 56.565 minus 9, because it's on the opposite side of the circle, which comes out to negative 31.177 megapascals.